very good evening and a warm welcome to today's hands-on bootcamp where you will get to build a fully working application in just under 30 minutes. I am 𝗖𝗲𝗿𝗁𝗂𝗏 and I'm the Director for Community and Partnerships with 𝗵𝗲𝗿𝗂𝗏. 𝗵𝗲𝗿𝗂𝗏 is a SaaS technology company supporting over 1 million developers worldwide build their ideas faster by reusing open source software. Our vision is to reinvent digital realization. Very simply put, we'd like to improve the way applications are built. We do this by investing in a unique combination of both public domain knowledge and artificial intelligence. So coming to today's bootcamp, this is an integral part of our 𝗵𝗲𝗿𝗂𝗏 community initiatives. The 𝗵𝗲𝗿𝗂𝗏 community is a body of like-minded technology enthusiasts and open source contributors who have come together with the vision of contributing to the world of open source and sharing how complex use cases can be developed by reusing open source. Over the last few weeks, we have run several such open source development bootcamps on a variety of topics, such as building your own AR-powered e-commerce site, building your own ChatGPT, building a breast cancer prediction engine, building an object detection engine, basics of Python programming, and many more to come. Through these bootcamps, you will realize that technology does not have to be complex and definitely does not have to be developed in silos. You will see how you can take a solution that is pre-built, in fact pre-built by many people in the world, and then you can build on top of it and share it back such that your solution can now be accessed by many other people in the world who can then further build on top of your ideas, thereby accelerating this virtuous cycle of innovation and also helping you scale your ideas and bring it to life much faster. So with that brief introduction, I will now welcome our mentor for today's session, 𝗖𝗲𝗿𝗁𝗂𝗏, who is a senior developer advocate with 𝗵𝗲𝗿𝗂𝗏.
Hello everyone and welcome to today's session on building your own fake news detection engine. So let's get quickly into the agenda for the day. We will talk about this problem, that how this is a very essential problem in today's time where everything that you read, the news that you share with one another is through digital media, and how you actually need an engine to check whether the news you are reading or catering you have been served with is real or fake. So we'll go through the workflow with the algorithm that we have selected and how you as a technology enthusiast can build a model of your own. So as we go through this process, we will do it through a complete one-click kit solution that you can also set up onto your systems. But in the meanwhile, we will also do a code snippet exercise that you can use to augment your knowledge in artificial intelligence, or let's say use of Python today. So before we go ahead with the session, I would like you to check out the solution that we are going to build out today. So this is our solution wherein we will use confusion matrix as one of the very essential matrix that can tell you whether how many news articles have been stated as real or fake. And with this Jupyter notebook, we have a 5,000 data set, which is saved in a folder. Let me also showcase you that. So we have our fake news data set that we will feed into a model. So this is the text, and we have a labeled data. So 1 is for a news which is fake, marked as fake. 0 is for a news which is marked as real. So we already have this data set which is having some 5,000 rows nearly, and we will feed this into our model, which is going to be trained on a data set, and we will use a naive based model here to do our prediction, or let's say the text classification. So based on the prediction that we have done, we were able to state most of the news as real or fake. So let me also showcase you the test file. We used a test file with some rows, and as we run this test file through our model, a test prediction file got generated. So what will this model result in? Based on the test file that I had provided, I got the labels as in whether a certain news has been stated as real with a good probability of 97%, and another news which is stated as fake with another very interesting probability of 96%. So we are getting a probability score of over 80% with the news being stated as real or fake. So 0 will be real news, and 1 will state that the particular news that you're reading is fake. So this is how our model is able to work. We are using three sorts of files, data files. One is your data set that is used to train the model. Another is your test file. And then this is where the prediction is showcased in terms of probability. So let's get started by setting this up onto your systems. To set this interesting fake news detection kit onto your systems, you have to get onto the community page where you are currently viewing this session. So you're currently viewing this session on this community page right here. And under the resources section, you will see that there is an option to click on the kandi one click kit button. So this button will take you to the kit page. Apart from this, we have listed down interesting coding exercises for you to augment your knowledge with this kit in artificial intelligence and also do interesting natural language processing steps. So we will do one of these exercises as well. And then you see that if you scroll down at the bottom, you have an opportunity to earn yourself an open source enthusiast badge. So this badge you can showcase on social media and showcase how you are using open source today. We have listed down the steps. Also, if you follow alongside with me, set up the kit, you can earn yourself an open source enthusiast by sharing a screenshot of what kind of a change you made to the kit. By for that, but you have to log in into this platform called community.openweaver.com. So that is one thing. Also, I already see people have started engaging with the platform through these polling questions. So go ahead and check out your knowledge on these questions as to where do you stand in terms of your understanding of open source as well as this current model, this current problem statement of fake news detection. So let's get to the setting up of kit. For that, click on this kandi one click kit button. This takes you to the kit page. On the kit page, we have the deployment information listed down for Windows and also for other operating systems. We click on this one click installer. It downloads a zip file. Go ahead and open the zip file in your local machine. Extract all the right click and extract all the contents of this zip file. Only after you have extracted the contents of this folder, double click on the folder. You will get a batch file, double click the batch file, say more info, run anyway. So this will start setting up this kit onto your systems. So this will take say 4 to 5 minutes depending on the bandwidth that you are on. So it will give you pop-ups. So it'll ask you whether you would like to install Microsoft Visual C++ redistribute. So you just have to say yes and let this setup proceed like it is proceeding onto my systems. So for now, I will minimize. You can minimize the screen if you would like, or you can let the screen be. And as the kit is getting set up, we can get back to the discussion on the concepts and the problem statement for today. So we want to talk about fake news detection. As we talk about this problem, why is it important that I want to detect a news as fake or real? So you saw that during this pandemic where we had the people sharing information through WhatsApp, so through Facebook, through all kinds of Instagram and social media channels, we saw that a lot of misguided information, misinformation was being circulated, and somehow this misinformation led people to a lot of chaos and difficulty during these difficult times. And not only this, fake news has a capability of influencing the way people make decisions. So social media is also used to turn uh, people's view on democracy, politics, the views of one country trying to manipulate the content that is being provided in another country, right, based on their own global interest. So fake news is not just about any information, any content that you're reading, but everything that you can, think of, which will result in influencing your decision overall, can be used to misguide you. So hence this is a problem that needs to be seriously tackled, and we want to use a data set that we have picked from Kaggle. We will be using our NLP, natural language processing technique. So whatever we work with in machine learning is, let's say we are using your natural language processing pipeline. So we will use the different steps to make the data in a form that your machine can use it. Okay, so we define this fake news problem as a simple text classification problem. We have the text with us, and then with that text we want to state it as fake or real. So to be able to state it as fake or real, we already have the target values also with the data set. I just showcased you right at the very beginning, the data set that we had. And then we are translating the news into your model features, and then those model features we are testing against a data set to see how well the prediction is being made. So we saw that there was a decent prediction of over 80% that was made, and our goal is we want to develop a model which classifies a given news article as either real or fake. So what are we going to do? In the model construction, we will be using a NLP pipeline. So we want to use a NLP pipeline. And how this NLP pipeline will be helpful? The first step is we do pre-processing. Okay. The step one is we do pre-processing. In this pre-processing, I remove the hashtags. Let's say I'm picking a Twitter tweet. I will do HTML tag removal if those HTML tags are there. Okay. Then step two is tokenization. So at the end of the day, everything is in the form of sentences. When I say we break them down into tokens, we are saying those sentences we are creating in the form of words. Now from those words, right? From those words, I want to remove all the unessential words. So English language has a lot of stop words. Is, and, the, all those are what? Stop words. So step 3 will be stop word removal, and then comes in your stemming and lemmatization and the TF-ID of vectorizer. So let's discuss it with the help of an example so that it becomes interesting for you to go through. So I've taken an example, a simple, very simple example of two statements. London is the capital city of England, standing on the river Thames in the southeast of the island of Great Britain. So what we are doing here, the step 1, I have removed and separated these two into two separate statements and removed the hashtag. Okay. Then in the step 2, which is your tokenization, we have separated London with the capital city of. We've just separated each and every word. Next step is stop word removal. So what we will remove? We'll remove is, the, of. Is, the, of, all these helping verbs, prepositions, all of these will be removed. Then stemming and lemmatization, what we do, we get to the root form of words. So currently in our sentence, we don't have any ing, ed, s. If we have a sentence, let's say he was talking to her about the current condition of floods or epidemic or something like that. So talking will become talk. Talks, talking, talk, everything will come to the root form, the base form, which is talk. Similarly, a word called cared, caring, will have the root form called care. So that is stemming and lemmatization. So there is a difference between these stemming and lemmatization. Lemma is where we are also getting to the meaning of the word. Sometimes what happens, I gave you an example of cared, caring. Lemmatization can be, actually keeping the meaning of the word, but stemming might stem it, might cut it in a way that care will become car. So car also has a meaning, but it has actually changed the complete meaning of the word care, right? So I hope you were able to understand that this difference between stemming and lemmatization. Very important to recognize what is more beneficial while you are applying these NLP processing, text processing techniques to get your data into the form that can be fed into the machine. Next comes your TF-IDF vectorizer. So this vectorizer is very helpful to transform the text into meaningful vector or number representation. So before you feed it into your machine learning algorithm, you need to make it in a form where when we are saying that we are using the TF-IDF vectorizer, what we are doing in the TF-IDF vectorizer, we want to measure the importance of, how do I say, like suppose there is a news article and I suppose already know, right? Because we have a supervised data set. We already know that when the news has this set of words, then these set of words clearly are able to say that the news is fake. So we want to measure the importance of the words. So for that, we have used this TF-ID vectorizer, wherein we have a factor called term frequency. So we try to calculate the occurrence of words and compare them. Like how do we compare? We compare them by the total number of times they have appeared in a document with the number of documents they have appeared in. Okay, so the more the word will appear, accordingly will be the value of your TF-IDF. Okay, the terms frequency, and you multiply it with the inverse term frequency to calculate the importance of the word. Then after we have passed it through this algorithm, we apply the actual machine learning algorithm, which is a naive Bayes. So what does this naive Bayes do? It helps us in building a time efficient model so that we are able to do quick predictions. And the interesting part is this model is very simple, highly intuitive, and works with the probability theory. So it works on the Bayes theorem. So it can be also used in spam filtration, sentimental analysis, where you want to define that based on people's reviews, a certain review is positive or negative. So you can use it at various problem statements. How does this naive Bayes work? So what we do, we find the occurrence of an event given the probability of another event has already occurred. So suppose what we are trying to say, we want to find if a news article is fake if certain words are already present in the news article. So that's how we are able to implement the concept of naive Bayes into our model. So we have these nearly 5,000 records or instances of news articles which were already labeled as fake and real. I also want to talk about the interesting aspect of open source. So we have, this solution that we are giving you. This is completely, you can reuse it, download it, customize it. You don't need to worry about that. It'll get you into some constraints. Reason being, it is under a permissive license. So anything that is open source can be used by anyone in the world. Only thing you need to check while you are downloading something from the open source community are these key considerations. You have decent support or not, whether you can get good support for what you are working around with open source. If the solutions are secure enough, it should not be malicious. And if there is good support and security, then obviously the solution gives you a decent quality support. Then comes in your license. So license is very important. If I say that it is under a non-permissive license, then you may have to download and use the solution and recontribute it back to the community depending on whatever the agreement is. So check for a permissive license. Anything that is under a permissive Apache, GNU, GPL license can be simply used by all of you. So all our kandi kits are free to use, customized by all of you. So now let's get to the kit. Quickly, let's get to our kit. And as we get to our kit, we want to see how you can. So by now you should have reached this point into your setup, and just use and say yes and enter. This will automatically open the Jupyter notebook in front of you. So before we go ahead and discuss this Jupyter notebook, I quickly want to do an interesting code snippet exercise with you guys. So how do you guys also get yourself, engaged with the exercise? Go back to the community page that we were before on. On that community page, if you scroll down, Under the code snippet section, you will find an option for these interesting exercises. So click on this link called spam filtering. Here, you would see that I tried to use kandi.openweaver.com, okay, this platform, and based on the search that I do, okay, if you see the search that I made previously was spam filtering for removing stop words. So I got many simple code snippets that I can just copy paste in my notebook and use it to develop a solution. So I will copy the first code itself, paste it into my notebook, and now check it if I require any correctness to be done in my code. So I see this is an outcome, so I will delete this part, then just run it and see. And I see that it has successfully been able to capture the essential tokens. Let's see how. You saw the data that was provided was ham, and how will do that. So all this came into something that is not important. The keyword princess is important. The question symbol is important. Even this colon is being preserved. Then this spam is removed. Ham and spam both is removed. Urgent is kept. Please call this number from landline, this cache, or whatever is the detail. So only the essential parts of the detail are what are being preserved here. So what did we do? Whatever is the data, for text in label underscore text, part 1 for your label text in data, in this data that you have stored, token for token in nltk.word tokenize. So from this nltk, we are using the word underscore tokenize on the text if token dot lower not in nltk corpus. So what is your natural language toolkit? This nltk is your natural language toolkit, which already has stored corpus. So what are these stored corpus? These already are text build up into this library. And what I'm trying to say, from the corpus I want to remove dot stop words. And what kind of stop words I want to remove? Which are English form. So this is already checking those words which are not in this corpus. So we these are our filter tokens. Okay. So this top word corpus will have what? It will have this. And how you will that, but it will not have princess. It will have ham, spam. So depending on whatever we have loaded in nltk.corpus.stop words, in that too, which language? English. If not, so whatever are not in the words are then filtered as tokens, and then these are simply printed here. Very simple but very interesting code snippet if you want to understand stop words removal or spam filtering in any data. So we just did a very quick exercise, and the effort that you had to make was minimal. Just go to the community platform, scroll and get to this first problem. Click on this. We have provided you the direct link. Copy paste this code into a notebook, run it and check the solution. And you can change the data if you would like. Just add something different also. Let's say Princess and Harry with something, with Prince Charles. Let us rerun it and check. So now you see Harry, Prince Charles, all this has come, but my and with, it still got removed. So you can simply do your own, stop word removal check onto a text data that you would like. So now I will take you to this notebook that we were working and discussing about. I will just restart and run all. So you also follow this command for your notebook. So what we've done, initially we have set two variables called an input file and a test file. So your input file is fake news.csv and your test file is your fake news test.csv. We have divided the test data ratio such that 80% of your data set is used for training and 20% is reserved for testing. from detect import fake news detection. So this is a library that we want to, we basically have created. I'll show in the folder detect. There is this file called detect, wherein the entire code for this fake news detection is present. So we can discuss this as well briefly. But in the meanwhile, I want to talk to you about this fake news detection, where we are first giving our data set and our test data ratio, which is your 80% from this input file that will be used for training. So now I will show you. This is our detect.py. This detect.py has the necessary imports for tokenizing the data, for stemming it, for feature extraction. So all these essential imports are made first. Then within this fake news detection class, we are reading our input file. Okay, the input file which we had passed earlier as a CSV here. Okay, then we are saying just print the head and also print the ratio. So you would see 5 rows were showcased because head shows the 5 rows, and this is the ratio. Okay, test data ratio. So then we further do the pre-processing of the same steps that we discussed in the natural language processing pipeline, where we had done the pre-processing on the input data. So step 1 is tokenization. We splitted them into tokens. Step 2 is your stop word removal, where again using stop words in English, we use the same, right? That if that is present, we just need the clean text. Then we have done the stemming process for getting the root form or the stem form of the word. Then you have implemented your TF-IDF vectorizer, your term frequency inverse document frequency vectorizer, which is used to get the important or the essential parts of or the essential words. Right, data is being passed to it. Then comes in your compute matrix. So this matrix is where we are doing the prediction. Okay, so if you see that we have prepared a classification and report and a confusion matrix. What is this classification, report, and confusion matrix? You see, this is the step 1 within the detect function. So all of this is defined within the detect function, where we first check that we have a data set of 4986 after removing the duplicates. Then we checked if there were any missing values. So there were duplicate values. So we had some 4749 after removing the duplicates. Then we had again 4749 because there were no missing values. So you can just check. I'll show you. We dropped the duplicates. We dropped, we dropped if there were any missing values, any values. So those got printed. Then we checked the shape of the training. Then we had this 4749, and these were your different words based on the number of rows and the news in it. So we had some 61,000 features, or let's say words, that were extracted from this. Then the split happened into train and test. The model got trained. We used Naive as our training model. The classification matrix showcased is this. So you see that a 93% accuracy is what was achieved on an average, where your 57 and 215 news articles were not correctly predicted. Rest all nearly more than 3,500 were correctly predicted. So after this training, we tested the model on the test data, and on the testing data, which is 20%, we were able to achieve a 77% accuracy. So with the 77% accuracy, we do have more values in error. But when we test it on the exact test file, which is your test file here, fake news text. Okay, this is the file that I showcased you, that we had some rows that you can copy paste here. And let me just showcase you. Then with the same file, this is what we got as prediction probability for these text that we had put in here. So interesting part is here you are able to check the shape of the testing data. Currently it is 6 with the same 61653 features, and 97 is the probability of it being real, and this is the probability of it being fake, again of being real. So this part of the probability is more, means it is real. This is less, means it is fake. So if you want to check it more properly, get into the model folder, okay, and in the model folder open the test spread file. All right, open the test spread file so that you are able to clearly get to this prediction part. Let me put in, sorry, delete I will just delete this file and rerun the model. Let me just delete this test spread, and in the fake news test, I'll just copy paste some more rows here. Okay, save this and then rerun this model. Restart and run all. Now, based on running the model, my test spread file should get generated with a different score. Let's check. So that will take some time because the code has to run through all of this. Okay. So here we have used the multinomial naive Bayes with this hyperparameter alpha of 0.1, so that we are able to get to a decent accuracy. So if you see, these are all this is the entire code that has to be processed before we are able to get to the result. Okay, let it take the required time. We just require the test spread file being generated. I'll just stop, maybe restart and run the kernel once again. Okay. Sometimes it does take more time. We can discuss a bit on our detect.py file. That's it. Like we were discussing on these parameters of the pre-processing and printing the shape. So currently here is where your model is running, right? Pre-processing part, and then comes in, you're splitting that data into train and test, and then training the model on training data set. Then you have initialized the model on multinomial naive Bayes, setting your alpha equal to 1. Next step, we fit the model on the training data, which is your X train, Y train. Then saving this model into a file. After that, we print that the naive Bayes model trained successfully. Classification matrix also, we define that we have your classification matrix. Then you have your X train shape, Y test shape, Y train, as well as your Y test shape. Then here comes in your okay, this is for the testing part, where you are getting to the test data, which is your 20%. First, you have loaded your model, which is with the help of pickle.load, and then further you are using your pd.process data, saving into features underscore df. You printed the shape of this test data, and then with the predict underscore proba is where you are trying to define the different features using which you are doing the prediction. So this test spread file is used for the prediction. Let's go and check back. So yes, our model ran. by now. And as it ran, we now have some 10 records, and this is the probability. So we'll go to the folder. We go to this testbed file, which just recently got generated. And you see, then this is the current probability with which it is able to make predictions. Okay, and most of your predictions are with a decent probability score of over 90%. I mean, that means the model is able to state that this news is fake with a 96% probability. So this is how that this model is what you can check on your own. You just have to copy paste the data. Where you have to paste it, just use the test file, fake news test file, copy paste the news article here, and then wait for this testbed file to be generated. So I think with this, we would get to the discussion on the solution that we discussed today. And this fake news detection that we discussed today, we tried to cover these few concepts on how you can use Bayes as your primary algorithm model to detect and state whether a news article is real or fake. Secondly, we use the TF-IDF factorizer to get to the words which were more important to be identified for a news article to be fake or real. And the interesting part about this was everything you curated in a single kit that we called a kandi kit. So you could simply get to the code directly that has been curated in, not just 1 day or 2 day. So you can use this code directly as it has been curated by a team of open source developers for you to use, just like how you're using many different Python modules for you. So I hope this was helpful, and we are now open to questions and look forward to your questions in the comments as well as questions from our community members going forward. So I would first take up this interesting question that has come from our one of our community members, asking the difference between stemming and lemmatization. So I think I did, I think this is a very important question that all of us should be aware where before we are applying stemming or lemmatization. I used stemming in the model because I was able to clearly use it as a stem portal. So there are different stemming modules and libraries as well. We chose the port stammer, and that port stammer is basically helping me get to the root form or the base form of the word. Again, giving you the example of walk, walking, walked. All of this will have the root form called just walk. So that is what is stemming. And when we are saying lemmatization, the interesting part is in lemmatization, you will not have to worry about the grammatical form of the verb. So the grammar will be maintained. So that is when you are more concerned about not getting a word, say caring, cared, cares, cut down to car. Then you focus more on the grammar or the lemma part of the word. So then you use a lemmatization module for it. Okay. We have another question from one of the members where they have asked us that can we also use any other algorithm. So yes, you can use logistic regression, you can use any other classification based model which can help you get to a quick result. You saw there were steps that were taken while we were doing the NLP pipeline processing. So you just want to reduce the time that is being taken to process your text. So choose an algorithm that you can wisely use to enhance the efficiency of the output. So with this, I think we have sufficiently answered the questions that we were having for this session. Thank you.
Thank you, Pooja, for that lovely session. For all our viewers and bootcamp participants, we hope you enjoyed the session and found the use case that was presented valuable. Please note that all of you who participated will be eligible to receive certificates for this bootcamp. In order to receive your certificate, please complete the assessment by answering 2 very simple questions. You can do that by scrolling down from on the same page where you're viewing the bootcamp today. You will find a Take Assessment button. Click that button and complete the assessment. You should then receive your certificates in less than a week from today. We will be conducting such bootcamps frequently and regularly. So if you'd like to stay updated with our program calendar, do join our community on community.openweaver.com. This community is where we will connect with you. It helps us receive feedback from you. It helps us understand topics for future bootcamps. But also you can use this community space to collaborate with each other, to ask us any questions and receive clarification if you'd like, or just share your projects and anything else that you would like to in the world of open source. So do join our community and also follow us on our social media channels to stay updated on information and trends in the world of open source. With that, I would like to thank you all for your participation today, and I look forward to seeing you in yet another bootcamp very soon. Thank you and good evening.